Welcome to ID the Future. I'm your guest host, Ira Berkowitz, coming to you from the ancient and still bustling city of Jerusalem. I live and work here in Israel's capital, writing, teaching, and counseling people. I've been interested in evolutionary theory for a few decades, but my real education about Darwinism and its problems has come from physicist Dr. Lee Spetner. His two books, Not by Chance and The Evolution Revolution, demolish Neo-Darwinism. Moreover, they explain cogently the evolution that we actually witness. Dr. Spetner's credentials are too extensive to treat at length, so I'll mention them briefly. In 1950, he received his Ph.D. in physics from MIT, after which he taught graduate-level courses at Howard University and Johns Hopkins University. For 40 years, Dr. Spetner worked in research and development and military systems management. Then, after his retirement, he worked for 12 years in cancer therapy research. Dr. Spetner has written dozens of published articles and holds quite a few patents to boot. He lives here in Jerusalem, and it is my privilege to interview him today. Welcome to the show, Dr. Spetner.
Thank you, Ira. I'm happy to be here.
I'm very happy to have you with me. Dr. Spetner, I want to focus today on your critique of modern evolutionary theory. Let's start with what is maybe your most shocking allegation. You write that Neo-Darwinism isn't even a theory. How can you make such a claim?
Well, that's because it doesn't have the trappings of a theory. You see, evolutionary theory as it exists today is based on random mutations and natural selection. At the core, it's a probabilistic theory. So in order to validate the theory, one has to calculate the probability of getting the events that are predicted by the theory. And only if these events have a probability that's rather high, the theory is validated. In other words, the theory makes certain predictions. So you have to show that these predictions really stem from the theory, which means that they have a high probability of occurring. And nobody has ever shown that the probability of these events predicted by the theory are anything but negligibly small.
Well, thanks. So we could leave it right there, but let's ask a few more questions in any case. What about the experiments done with soil bacteria cited by Jerry Coyne? You've said that Darwinists haven't done the necessary probability studies, but at least it looks like we have evidence that random mutations can add information to the genome, no?
Actually not. These experiments that Jerry Coyne cited in his book of a couple of years ago were the same experiments that I treated in a book of mine about 20 years ago or more. And there I showed that there was no information being added to the genome. It looks very good superficially. There are 3 mutations that occur successively, and each one seems to make the bacteria grow a little bit better. But it turns out that what happens is that there were indeed 3 random mutations, but 2 of them made things better by disabling a repressor, which opened up a gene to encode the enzyme full blast, which was a little bit better for the organism. But since it was disabling a repressor, it really lost information rather than gained the information. And the 3rd mutation was actually a decrease in the specificity of the enzyme, which meant that before had worked only on ribitol and almost negligibly on any other substrate. But after this mutation, it increased its activity on xylitol and decreased the activity on ribitol, which looks superficially like it's changing the adaptivity of the enzyme from one sugar to another, but that isn't true because there was a 3rd sugar that it also raised the activity on. So in decreasing the activity on ribitol and increasing the activity on xylitol and on the 3rd sugar, L-arabitol, it's showing that it's actually decreasing the specificity. And decreasing the specificity is losing information and not gaining information. And these 3 mutations are not the sort of things that you can build evolution on. Disabling repressors isn't leading anywhere. Decreasing the specificity of an enzyme also doesn't lead anywhere from an evolutionary point of view. So these experiments were not an example of evolution and were not an example of information being added to the genome.
So just because a mutation is adaptive, it doesn't mean that more information has been added. In our case, less.
That's correct.
Okay, so bacteria, they've become more resistant to antibiotics. So that's been cited as a case of random mutations leading to adaptations, right, to evolution, no?
They've been citing this for the last 50 years with the mantra that if you can get evolution-like resistance to bacteria, antibiotics in 10 years, if you let this continue for millions of years, you can get all kinds of wonderful things. Well, that's just not true because, first of all, the way bacteria gain resistance to antibiotics is done in many ways, and most of them involve non-random mutations. They involve what's called horizontal gene transfer. They are able to transfer resistance genes that exist in other bacteria and buy them for themselves so that they become resistant. And the bacteria that are already resistant are sending their genes out into the medium which are picked up by these bacteria. You might want to ask, why do those bacteria have resistance genes and where do they come from? And if you want to know, I'll tell you, because there are bacteria that manufacture antibiotics. In fact, that's where we get our antibiotics. We take them from these bacteria or we copy them from what they produce. And these bacteria are known to have been able to manufacture antibiotics for a long, long time. And of course, if they manufacture antibiotics, it's reasonable that they should have resistance genes so that they protect themselves from their own antibiotics. So by some bacteria capturing these resistance genes and becoming themselves resistant doesn't add any information to the whole biosphere.
If I borrow a book from you, it doesn't mean that there's more information in the world. It's just another copy of the book.
That's right.
Dr. Spetner, I want to turn to Thomas Malthus, who provided the philosophical underpinnings for the theory of natural selection. Charles Darwin hit upon it and said, that's it. That's the idea. And so you bring up in your book that it's not, and I'll just briefly fill our listeners in. Thomas Malthus argued that human population tends to increase exponentially, while the food needed to support that population only increases arithmetically. So this would mean that human populations would eventually have no resources to live on unless they were kept in check. Barring abstinence or birth control, human populations would have to rely on famine, war, and disease to keep their numbers down. In short, life would have to be miserable if it was to be maintained at all. So you argue that Malthus's idea can't be applied to the natural world. So would you fill us in?
Yeah, according to Darwin and Malthus, you'd expect animals and plants to always be living on the ragged edge of survival. According to Darwin, if they're always struggling so that only the adaptive ones will survive, they're living a miserable existence. Well, it's not true. Actually, they live pretty well. And animals and plants, too, have the ability to adjust their own reproduction to keep in line with the resources that are available. There was an experiment that I heard many years ago, an island that contained a population of wolves as predators and deer as prey. And the wolves would survive on the deer, but they never overate the deer population so that the deer population never went down to zero, which would make the wolves become extinct. Instead, if the deer population decreased because of a drought or whatever, the wolf population would decrease in synchrony so that it continued to survive on a small enough amount of the prey population so that it kept its numbers up so that they would always have food to eat in the future. So the whole idea is just not true. It's a conjecture coming from Malthus, but if you look at the real world, you'll find that many, many animals control their own population and do not overeat their resources. They maintain their resources so that it continues well into the future.
Astonishingly, this happens even in the plant kingdom, isn't that true?
Oh, yes. Plants also. If you plant things too close, then the plants seem to detect this, and when they send out seeds again, they will send them out far so that they would disperse so that you don't have an overcrowding. This happens in birds, too. Birds don't overcrowd. Then they each take up their own little area, and the population does not increase to such an extent where they're overpopulating.
So there's a built-in mechanism that preserves the species, not just the individual.
That's right. Mechanisms seem to be built in to preserve the species. There are built-in mechanisms that are the ones that really drive the evolution that we see. We do see some evolution, and this evolution is driven by built-in mechanisms.
Well, our time is running short, and we've obviously only scratched the surface. I want to get to that next idea another time, but hopefully we can have you on for another episode.
Yeah, that would be very nice. I would like to, because there's a lot to talk about.
Excellent. I'd like to remind our listeners of Dr. Spetner's two books, Not by Chance and The Evolution Revolution, both available on Amazon. This has been Ira Berkowitz from Jerusalem, thanking you for listening to Intelligent Design, the Future.
This program was recorded by Discovery Institute's Center for Science and Culture. ID the Future is copyright Discovery Institute. For more information, visit intelligentdesign.org and idthefuture.com.